So in this video, we're doing question 6, and we are answering a question about the hyperbola. So check out on the previous video, we've done a lot of questions, 1 to 5. In this video, doing question 6. This is grade 10, November 2018 revision paper. So yeah, so I'm going to give you a note on hyperbola functions and then help you answer this question. It's going to be 12 marks, so I'm going to make sure that you understand these 12 marks and you get it every time when you see the question like this, right? Not always going to be a question like this, but the basics that I'm going to be teaching you, they're going to be a basics that you're going to need. So yeah, so thank you for joining. Don't forget to like, subscribe, and make sure you write a comment if you like this video, and write a comment if you have any questions that you have on this video. So let's go. So first question says the equation of a function, and they give us a generic equation of function g of x equal to a over x plus q, passes through the point 3 2 and has a range of y from negative infinity to 1 to infinity. Okay, so let me give you a general understanding of hyperbola, right? So just give you like rundown notes what you actually need to know. This is a revision. So essentially what you need to know is, if you have an equation, let's call it for argument's sake, let's just call it y is equal to a over x minus p plus q. This is a general equation of a hyperbola, right? So the first thing you need to know is the asymptote. So you have a horizontal asymptote, and the horizontal asymptote in this case is y is equal to q. That's your horizontal asymptote. And you have a vertical asymptote, and the vertical asymptote is x equal to p. What do I mean by that? Let me give you a picture. So let's say you have a Cartesian plane, and then you are told that you have a horizontal asymptote maybe of y is equal to 2. That is a line where your function is not going to touch. And also, let's say you are told that you have a horizontal asymptote of x is equal to let's say x is equal to 0. So that means this is your horizontal or vertical asymptote. So that means that your graph won't touch this line, and your graph won't touch this line, right? And for some reason, so the way you write this, your graph is either gonna be here. If it's there, therefore it's gonna be here as well. So that's how the hyperbola look like. Or if it's here, therefore this side is gonna be here, and that's how your hyperbola look like. So let's say, for argument reason, you'll see it how that's gonna look like. Of course, you need to calculate your x-intercept and y-intercept to figure out which one is which. That the x-intercept and the y-intercept will tell you whether it is here or here. Okay, so your x-intercept and y-intercept will tell you where it is. So, but let's just assume that this is where it is. Okay, so if this is where it is, one thing you need to know here is what you call this line here. Let me just draw a solid line. Is this line here? So this line here is what you call an axis of symmetry. An axis of symmetry, this line basically says you have y is equal to x plus q. It can be positive or it can be negative. Okay, so if it's negative, that means your line is decreasing. As you can see, this line is decreasing, so therefore your axis of symmetry is this one. If it was increasing like this, therefore your axis of symmetry will be that one. So if the line was increasing like that, therefore if we have this and have that, that's a line of axis of symmetry. Therefore your line of axis of symmetry will be this one. Make sense? But in this case, the line of axis of symmetry is this one. Y is equal to negative x plus q. And q is this horizontal asymptote. This asymptote. In this case, would be y is equal to negative x plus 2 instead of q. And an axis of symmetry is basically a line that cuts this graph at the in sort of in symmetric shape, right? So you can already see that it cuts this half, and then it cut that half over there. So it cut the graph in a symmetric shape. So those are the two things that you really need to know here. Number one, you need to know your x's y-intercept, and your your asymptote, the horizontal asymptote and the vertical asymptote. And you just need to know the axis of symmetry, the equation of axis of symmetry. Those two things, if you know these things, can able to answer any parabolic question, right? Those are the main basic, and I want to give you like boom boom. I don't want to stress around all the theory. This is what you need to know. If you know this, if you don't understand, please let me know. Just feel free to ask any question. I'll be here, happy to help. So I'm looking forward to your question on this one. So now let's go back and let's read and understand what's happening here. 6.1. So they say the equation of the function g of x is equal to a over x plus q. So that's the equation of the function that is given us. They say this equation passes through point 3 and 2 and has a range of y is an element. That's how you read this. Y is an element of negative infinity and 1 union 1 and positive infinity. So that's the range of this function. So what does this really mean is you have, let me just write it down for you. Let me write a picture for you. So you have a rough picture. So you have, let's say you have your Cartesian plane, and they tell you that this equation of symmetry passes through 3 and 2. So it passes through 3 and 2, and 3 and 2 is essentially somewhere here on the on this first quadrant of the Cartesian plane. So that's where 3 and 2 is at, right? So it's passes somewhere here, meaning it's gonna be like that because 3 and 2 is here. So we're gonna have a situation where it's like this, but we need to be able to figure out our y asymptote and x asymptote, and you already can see that we have a situation where this is g of x is equal to a over x minus 0 plus q, right? X is equal to x minus 0, it's the same thing. So our vertical asymptote in this case is basically x. Our vertical asymptote in this case is basically x is equal to 0, because our p in this case is 0. So our vertical asymptote, we're having a situation where this is our vertical asymptote, right? That is our vertical asymptote, x equal to 0. This is our vertical asymptote, meaning our graph, this function, it won't pass through this y axis. So it's essentially moving here, right? So it's gonna move here. And why is moving there is because we know that we have a point called 3 and 2 here, somewhere here. Make sense? So essentially now we need to figure out our horizontal asymptote, and the horizontal asymptote is y is equal to q, and we need to figure that out. But they say our range is an element, our range moving from negative infinity to 1, and from 1 to infinity, from negative infinity to 1, and from 1 to infinity. So what does that mean? It means that our y value from negative infinity goes negative infinity, and then when it reaches 1, let's say this is 1, it reaches 1, it doesn't touch that point, because that's what a horizontal asymptote is. A horizontal asymptote is a point where the graph won't touch, and then from 1 it moves again to infinity. So at this point, we're being told that at this point, positive 1, at this point it doesn't touch. So that means this is our horizontal asymptote. So at this point, at point 1, it doesn't touch. This is our horizontal asymptote. So that's basically how this look like. So meaning, therefore, our q is equal to our q, or horizontal asymptote, is equal to 1. Therefore our Q is equal to 1. Make sense? So in this case then we have a situation where you have what we are given is g of x is equal to a over x plus q, and what we have discovered now is q is equal to 1 because q is a horizontal asymptote, and the horizontal asymptote, from this we know that it says that it goes from negative into 1, it doesn't touch 1, and from 1 it goes to infinity again, from negative into 1 and from 1 to infinity. So that means at this point it doesn't touch, but we have a solution like this, and then we have another one that side. So our q is 1. Okay, and again, so if you have a question on this one, please let me know. I'm happy to assist. And from here, what we need to do then, we are also given that when the x value is 3, the y value is going to be 2. So we can just substitute those values here on the equation. So where there's x, just put 3, sorry, because we know that when the x value is 3, the y value is 2. So when the x value is 3, the y value is 2. So you have 2, g of 3 is 2, is equal to 2. So 2 is equal to a over x plus 1. Then now we can solve for x. Sorry. Let me go back. So when the x value is 3, so meaning where there's x, we just put 3, right? Plus 1. And we know that when x value is 3, the y value is 2. So g of 3 is 2, so we have a over 3 plus 1. Okay, then now we can solve for a, because we know the value of x is 3 and you know the value of y is 2, and that is given over here. And then so you can solve for a. So what I need to do is I can just take that 1, put it on the left hand side, becomes negative 1. So you have 2 minus 1 is equal to a over 3, and this is 1 is equal to a over 3. Therefore a is equal to 3. So that's your answer. So your a is equal to 3. Therefore your equation here, the equation is equal to a is 3 over x and q is 1. That's your answer. And you will get mark for discovering 1. Get mark for discovering q, and you get mark for substituting this given point 2 and 3, and you get a mark for this. That's where you get your 3 marks. To question 6.1.2. So this was 6.1.1. So I'll write it down what we already know. 6.1.1, what we know is this. So we know now that g of x, g of x is equal to 3 over x plus 1. That's what we know. That is 6.1.1. But with 6.1.2, let me wrap this off because we're not going to need it. We're going to need those notes over there, so let's just write this off for now. So with 6.1.2, so the equation h, determine the equation of h. The axis of symmetry of G, which has a positive gradient. Okay, so now they want us to find the equation of h, and the equation of h is an axis of symmetry of G which has a positive gradient. Now again, revision, the axis of symmetry, we have already discussed them here, that an axis of symmetry is a line that cuts the hyperbola symmetrically, right? And we said we have 2 equations. The first equation is y is equal to x plus q, and this is when the gradient is positive gradient. Why? Because this is a positive gradient. Or y is equal to negative x plus q. This is when we have a negative gradient, meaning a positive gradient, meaning the line is facing that direction. A negative gradient means the line is facing that direction. So these are the general equation of a axis of symmetry, and in this case we already know it's easy. Actually, this question is easy In this case, we already know what is q. Our q is 1, so we just substitute that 1 in the equation. So you have y is equal to negative x plus 1. And remember, what is the equation again? Equation of h. Determine the equation of h, the axis of symmetry of G, which has a positive gradient. So it's not going to be negative gradient, it's going to be a positive gradient. So it's going to be a positive gradient. So h of x is equal to x plus 1. Why I write h of x? Because they told us that the equation is h. So we wrote determining the equation of h. So you don't have to say y is equal to that when they tell you that your y is h. So you just have to write h of x is equal to x plus 1. And then you get your marks by sort of saying your q is 1. So get the mark for that, and then also identifying that you're taking a positive gradient instead of a negative gradient. So cool. So we have now axis of symmetry, and we have let's go back again. We have axis of symmetry and we have the equation. So you have an axis of symmetry. Axis of symmetry is x plus 1. This is 6.1.2. Now let's go to 6.2. Now 6.2 is going to be easy. 6.2 is going to be easy because now we already have the information that we need. They say now sketch the graph of h and g on the same system of axes. Clear show all the asymptote and intercept with x is 4 marks. So you're able to show your asymptote and the intercept. Okay, so what we have g of x, we have h of x. That's what we have. And first thing first, they want us to show the intercept. So with intercept, we have two intercepts. We have the y-intercept. So the y-intercept, what you're saying is you let x equal to 0. So for well, let's just start with g. For g of x, okay, for g of x, you let x is equal to 0. So where there's x in this equation, you're gonna put 0. So you're gonna have g of 0, where there's x, you have 3 over 0 plus 1, because this is 3 over x plus 1. And then this is not, it's not defined because 3 over 0 is undefined. So therefore what this means that our x can never be equal to 0. So you can never have a situation where x is equal to 0. So we don't have a y-intercept, right? Just keep that in mind. Now for h of x, okay, let's do that. So h of 0, so remember h of x is this one. H of x is equal to x plus 1. So where there's x, we just put 0. So h of 0 is 0. So the intercept is when x is 0, y is 0. So that, is 1, because 0 plus probably a small one. 0 plus 1 is 1. So when x is 0, y is 1. So this is our y-intercept of h. And then now we can have the x-intercept. We can have x-intercepts for h of x and x-intercept for g of x. So let's continue like that. G of x. So the x-intercept, we say the same thing. Let y is equal to 0. In this case, we are letting g of x is equal to 0. And what is g of x again? G of x is 3 over x plus 1. So you have 3 over x plus 1 is equal to 0. Okay. And that's what you're doing. And then you can just take that 1 to the right hand side. You have 3 over x is equal to negative 1. Change the sign. And then cross multiply. So your negative x is equal to 3. Therefore, your x is equal to negative 3. So your x-intercept of g of x is negative 3 and 0. Right? When y is 0, your x is negative 3. Now, let's do the same thing for h of x. So h of x again, what we're doing is you let y is equal to 0, so you're letting h of x equal to 0. And h of x is x plus 1, so you have x plus 1 is equal to 0. And then take that 1 to the right hand side, becomes negative 1. So x equal to negative 1. So when x is negative 1, y is 0. So that is your x-intercept. So you have your x-intercept and the y-intercept, so you get marks for that. So you're gonna get a mark for identifying this, get a mark for identifying this, so 1 half, get a mark for identifying this, getting a mark for identifying this, so half, so it's 2 marks. And then so that's your x-intercept, and then now you need to get a mark for asymptote. So they say clearly show all the asymptote and intercepts, right? Clearly show them all. So of course you also need to show them in your picture, right? So you have clearly get your asymptote and intercept. So let's get the asymptote. Again, what is our equation? The equation, we already have defined our asymptote, right? Remember, we've defined our asymptote on our previous video. If you haven't, just check our previous video when we're doing 6.1.1. we already defined our asymptote there, and our asymptote here is it's not a previous video. If you're watching along from its video, just go back. If you're watching a short format videos, just check out previous videos, because I cut these videos to short formats for TikTok. So 6.2, so what you're saying here is you need to find an asymptote. Okay, an asymptote, we have two asymptotes. We have x asymptote is equal to 0 and y asymptote, which is equal to 1. Those asymptotes that we found, just go back a little bit to see it, or go to the previous video if you're watching this on TikTok. And so this is x equals to 0 and y is equal to 1, and then from here we can now draw our graphs or sketch them. So number 1, the asymptote, this is in our asymptote, x equal to 0, that's our asymptote. Remember, this is a y axis, is x-axis, so our asymptote x equal to 0, and then our horizontal asymptote is this one, y is equal to 1. So meaning then, and also remember we are told that we have a point 3 and 2 there, so that's fine. So that means our graph works there. It's gonna go past here, and remember that 3 and 2 over here, 3 and 2, right? If this is 2 and this is 3, so we have that point, and then also we have this point as well. Okay, move it there. But what is our x-intercept? Our x-intercept is for g. Remember, we're looking at this is g. For our s-intercepts for g is -3 and 0, so this is -3, this point is -3, so it touches that x-intercept, right? And then our h of x, remember, is what you call a horizontal axis of symmetry. So go back to our previous video, or go back to the video to just check out what is h of x. But we've discovered that the h of x is, this is the equation, and we know that x-intercept of h of x is what is h-intercept? It's -1. So this graph touches -1 there, so meaning it's gonna go all the way from this and cuts this over here. I know this doesn't look like a symmetric, but it does look symmetric, and also it passes by 1 as well. So because remember, the y-intercept of h is 0 and 1, so it passes through the asymptote. Boom. So this is your h, and then the final mark will be just writing this down. So how many marks? 4 marks. 1, 2, 3. Which one am I missing here? I'm definitely gonna give you a mark for asymptote. Yes, give you a mark for asymptote. 4 marks. Yeah, there we go. So get a mark for asymptote, get a half marks for all of these x-intercepts and y-intercepts, and get a mark for the correct picture. So this is how you're actually getting marks. Yeah, so if you get a correct picture, you're gonna get a mark for x-intercept and y-intercept and x-intercept to get marks for that as well. Okay, cool. Let me know if you have a question on this one. but in this video, but nextly I want to just talk about 6.3, right? So let me just wrap this off and then we can just jump to 6.3. Okay, so 6.3 is a little bit easy. It's not that complicated, so you just have to read through it. So what they're saying here is write down the equations of asymptote of f if f of x is equal to negative g of x plus 5. So what is g of x? G of x is, we can write that down, is a over x. In fact, you know it is 3 over x plus 1 plus 5. So that's what you got. So f of x is equal to this. And you can now simplify this one. So this is equal to negative 3 over x minus 1 plus 5, right? And then this is equal to negative 3 over x. Negative 1 plus 5 is negative 4. So f of x is equal to negative 3 over x minus negative 4. And remember again, what we talk about asymptote, we say this is a general equation of a parabola or hyperbola. Says a over x minus p plus q, and we have two asymptotes. And number one, we have a horizontal asymptote, and the horizontal asymptote is y is equal to q, positive q, because we're looking at this one. If it was negative q, this was going to be negative as well. And then our vertical asymptote is x equal to positive p. So positive p. So if this was positive p, this is going to be negative p. That's the difference. So using that information, looking at this one, you already see this is negative 3 over x minus 0 or plus 0, doesn't matter. If you want to say plus 0, minus 0, if you minus or add 0, it doesn't matter what it is. So your vertical asymptote is x is equal to 0. Why? Because p, our p in this case, is 0. And then your horizontal asymptote is y is equal to 4. And remember, it's not just 4, but it is negative 4, right? Negative 4. It is negative 4. Remember I said plus q? That whole plus q is negative 4. So these are our two horizontal asymptotes that they want us to find. And it's 2 marks. So yeah, so it's 3 marks. So you just get 1 mark, red pen please, 1 mark, 1 mark, and you get a mark for substitution. Boom. So that's those are your 3 marks. This is how you would smash this question, and it's a little bit easy. The things that you really need to know are these notes. See you on the next video. Thank you for liking and subscribing to the channel. If you are new to the channel, welcome. I really appreciate you, and I've created this channel specifically for you, trying to help you do well in your mathematics. And I'm creating this video just for you, not for fun, but I'm trying to help you do well. So I want you to, if you appreciate these videos, please make sure you like them. This is gonna help to grow the channel, and it's gonna help me to, it's gonna encourage me to create more and more videos, because I know that you are here listening to these videos and getting the help that you need. I'm gonna see you in the next video. We'll be finishing this paper on the next video. Hopefully I'll see you there. And make sure you tell your friends about this channel, and let's grow together. And if there's something that you want us to do and improve, please let me know. I'm willing to improve just for you, because I am doing this essentially for you. Boom.